You're welcome to Educational World. In today's video lesson, we'll be looking at a very important topic which comes out in WAEC mathematics examinations yearly, and that topic is the longitude and latitude. We'll be looking at this topic in-depthly, and if you find this channel informative, I would like you to subscribe. Okay, now we'll be looking at the picture of the globe. Okay, from the equator to from Africa to all the continents, as you can see. Now we move to the South Pole. So I want to show you the picture of the South Pole, because if you have a clear imagination of how the globe is, you can be able to understand the concept of longitude and latitude effectively. Okay, so that's the South Pole. Now we are moving back to the equator, and Africa is found or located around the equator. So now we are moving to the North Pole. So that's the picture of the North Pole, how the North Pole is. Okay. Now we are going to look into longitudes. What are longitudes? Longitudes are imaginary lines that run from north to south. Okay. Now, an example of a longitude is the Greenwich meridian, or which is sometimes known as the prime meridian. It is an imaginary line it cannot be seen. It runs from north to south, and it is located at 0 degrees. Every other longitude is measured 180 degrees towards the east or 180 degrees towards the west of the Greenwich meridian. Okay. Now, every longitude is a great circle. What are great circles? Great circles are those circles that have the same radius as the radius of the earth. That means the value of their diameter is the same thing as the diameter of the earth. And also they can divide the earth into 2 equal parts. So every great circle can divide the earth into 2 equal parts. So the Greenwich meridian is a great circle, and every other longitude, they are all great circles. So as you can see, imaginary lines running 180 degrees towards the east, okay, and the other ones going 180 degrees towards the west of the Greenwich meridian. So that's how the longitudes are measured. They run from north to south, but they are measured 180 degrees towards the east and 180 degrees towards the west of the Greenwich meridian. The next thing we are going to look at is what we call latitudes. Now, latitudes, they are imaginary lines that run from east to west. Okay, they all run from east to west. An example of latitude is the equator. The equator is the only latitude that is a great circle. Every other latitude is a small circle, which simply means that their radius is less than the radius of the earth. Thereby, they cannot divide the earth into 2 equal halves. So small circles cannot divide the earth into 2 equal halves, and they have a lesser radius to the radius of the earth. So latitudes, they run from east to west, but they are measured 90 degrees towards the north or 90 degrees towards the south of the equator. Equator is located at 0 degrees. Okay. Every other latitude is measured 90 degrees from the equator towards the north and 90 degrees from the equator towards the south, as you can see. Okay. Okay, now how can we locate 2 points on the Earth's surface? Points can be located, or places can be located on the Earth's surface by simply the intersection of the latitude and the longitude of that location. Okay, for instance, we have 2 places, point A and point B on the Earth's surface. Point A is at latitude 45 degrees north and longitude 50 degrees east. while point B is at the same latitude 45 degrees north, but this case longitude 20 degrees west. There is something I want you to take note of. That is the value of the radius of the earth. The value of the radius of the earth is 6,400 kilometers. Take note of that. So even if you are not given the value of the radius of the earth, it is a constant, and throughout our calculation in this topic, that is what we'll be using, 6,400 kilometers. Okay, now the next thing we are going to look at is what we call the radius of small circles. Now, just like the name implies, small circles, that means that their radius is smaller than that of the earth. So whenever a place is located on a latitude which is not the equator, that means that the radius must be smaller. We have to be able to find the value of the radius of that latitude, which is very, very important. We must be able to get the value of the radius of that latitude. Now, from the picture you are seeing, okay, now we have latitude 40 degrees north. From the center of the earth, latitude 40 degrees north is like an angle of elevation from the center of the earth 40 degrees upwards. Okay, so we can see the radius of the earth. Now we can see the radius of that latitude written by a small letter r, why big R is the radius of the earth. Now when we project the radius of that latitude towards the radius of the earth, as you can see, and complete it like a right angle triangle, we can now use trigonometry such that small r over big R is equal to cosine 40 degrees. Now, making small r the subject of that formula, so the radius of that latitude becomes big R cosine 40 degrees. Now, this is a very important formula, or a very important relationship. This simply means that the radius of any given latitude is equal to the radius of the earth multiplied by the cosine of the angle of that latitude. Whether it is latitude towards the north or latitude towards the south, wherever it is, the value of the radius of that latitude will simply be the radius of the earth multiplied by the cosine of the angle of that latitude. Okay? So that's a very, very important relationship. The radius of any given latitude is equal to the radius of the earth multiplied by the cosine of the angle of that latitude. So take that to memory. Okay, now we are going to look at small example. Okay, now find the radius of the circle of latitudes listed below, while we take the radius of the earth, big R, to be 6,400 kilometers. So we have A, find the radius of latitude for 56 degrees south, and B, find the radius of latitude 30 degrees north. So one is 56 degrees south, while the other is 30 degrees north. So we are going to look at these scenarios, or these two cases, separately. So the first one will be 56 degrees south. Now, in any problem concerning longitude and latitude, it's good for you to have a very good sketch. Okay, so that is the globe. So that's the equator. Now, the other latitude you are seeing there is latitude 56 degrees south. So that's the equator at 0 degrees. That's the radius of the equator. Okay, and this other one is the radius of latitude 56 degrees south. Okay, so 56 degrees is an angle of depression from the center of the earth downwards. And you can see alternate angles are equal. Now, when we complete the right angle triangle, now it now brings us to the same relationship, which says that R is equal to big R cosine theta, while theta is the angle of the latitude. Okay, so when we put in the values where necessary, so the value of the radius of the circle of latitude 56 degrees south will simply be 3,578.83 kilometers when we multiply everything out. It's as simple as that. So if we have latitude 56 degrees south, the value of the radius of that latitude is simply the radius of the earth multiplied by cos 56 degrees. So the same thing goes to the second question when we have latitude 30 degrees north. So we are going to look at it now. You can even go ahead and solve it before me. So we have the equator. That's the equator. That is the latitude 30 degrees north. Equator is 0 degrees. Latitude 30 degrees north is 30 degrees from the center of the earth upwards. An angle of elevation from the center of the earth upwards. So the small r is the radius of that latitude 30 degrees north, while the big R is the radius of the earth. So considering the right angle triangle formed there, and by trigonometry we simply have the same relationship that small r is equal to big R cos theta, and putting the values where necessary, we simply find that the radius of that latitude is simply 5,542.56 kilometers. Just as simple as that. Okay, there's no big deal about this. I hope you are getting this now. Meanwhile, if you find this video informative, click the like button and subscribe button. Okay, the next thing we are going to look at now is distance along small circles, that's along the parallel of latitude. Now, when we have two locations along a latitude, 2 points, 2 places are located along the latitude, the first thing we have to do is to find the radius of that latitude. Thereafter, we can now go ahead to find the distance between those 2 places. So we have an example here. 2 places on the same latitude, 20 degrees south, lie respectively on longitudes 10 degrees east and 80 degrees east. Find their distance apart measured along the parallel of latitude. So that is the equator. Okay, that is latitude 20 degrees south. Okay, now this is longitude 10 degrees east, while the other one is longitude 80 degrees east. Now that's the radius of the earth. Now the other small r is the radius of the latitude 20 degrees south. Now from our relationship, the value of the radius of that latitude is simply the radius of the earth multiplied by cosine of the angle of the latitude, and with that in mind, the value of that radius is 6,014 kilometers. So we can now see, when we consider those 2 positions, as you can see from the diagram, the angle between them, the angle between the first place and the second place, is simply the difference in their longitude, which is 80 minus 10, and the angle between there is 70 degrees. As you can see in that picture you are seeing there, the angle between the 2 places is 70 degrees. So the distance along the 2 positions can be seen as an arc of a circle which subtends an angle of 70 degrees in between them. Okay, it's just as simple as that. So that is the picture there shown. That is the arc. That's angle 70 degrees subtended in the middle. That is the radius of 6,014 kilometers. Now the length of that arc can be found with the formula theta over 360 is times 2 pi r. Okay, and when we substitute the values where necessary, that means the distance between those 2 points or those 2 places is simply 7,350.4 kilometers. As simple as that. You can see, first of all, we found the radius of the latitude. After that, we found the angle between the 2 places, and then used the formula for the length of arc, and we got our value. As simple as that. That is how to find the distance along the parallel of latitude. Don't forget that if you find this video informative, hit the subscribe button and the bell icon for notifications when I upload other videos. So distances along great circles are usually distances along the same line of longitude. What that simply means is that the 2 places, they lie on the same line of longitude, but they have different latitudes. So we'll be looking at 2 case scenarios here, where the latitudes are all northwards and where one latitude is towards the north and the other one towards the south. So that's what we'll be looking at now. So we have the globe, we have the equator, that's the latitudes. One is latitude B and the other is latitude A, all towards the north. Now that's the longitude that connects the two latitudes. Okay, so latitude A is at alpha degrees towards the north, while latitude B is at beta degrees also towards the north. Now the angular difference between the two positions A and B will simply be the difference in the angle of their latitudes, which is the difference in alpha and beta. So the angle between A and B will be alpha minus theta. So if you want to solve problems in this kind of scenario, we just use that theta and use the formula for the length of an arc to find the distance apart. Now we are going to look at the second case scenario. So in this scenario, we have the two latitudes. One is latitude A towards the south and the other one is latitude B towards the north. And we have the longitude joining the two places together. So latitude A is at alpha degrees southwards towards the south of the equator, while latitude B is at beta degrees towards the north, that is north of the equator. Now since one position is towards the south and the other is towards the north, now the angular difference between the two positions will simply be the sum of the angles of their latitudes, that is the sum of alpha and beta. So if we have a case scenario like this, we simply use the sum of the angles of the latitudes and go ahead and solve our problem. So we're going to look at example on distance along the great circles. So we have A and B are two places on the Earth's surface. If A and B lie on the same line of longitude such that A is on latitude 30 degrees north and B is on 50 degrees south, find the distance between A and B. So we're going directly into the solution to this problem. So we have the globe, that's the equator, that's the first latitude, and that's the second one. The first one is at 30 degrees north, while the other one is at 50 degrees south. Now that's the longitude that joins the two latitudes together. Okay, so latitude B is a 50, the angle there is 50 degrees south, while latitude A is 30 degrees northward, that's north of the equator. So the angular difference between the two positions A and B will simply be the sum of the angles of their latitude respectively. So it will be 30 degrees plus 50 degrees. That will be the angle between them. And don't forget that every great circle have the same radius as the radius of the Earth. So we don't bother to find the radius here, because the radius here is simply the radius of the Earth, okay, which is 6,400 kilometers. Now this simply is an arc of a circle AB which subtends an angle of 80 degrees between them. So we are now going to use the formula for the length of an arc to find the distance AB. Okay, so distance AB will simply be theta over 360 times 2 pi r. That r is the radius of the Earth, while the theta there is 80 degrees. And substituting the values where necessary, so the distance AB will simply be 8,939.68 kilometers. That is that, as simple as that. So I have an evaluation question for you to do here, and I want you to pause this video at its time and try and tackle this problem. And I also have my solution for you. So the problem is this: two places are on latitude 37 degrees south, and their longitudes are 34 degrees west and 29 degrees east respectively. What is their distance apart measured along the parallel of latitude? Now in this case, the two positions, they are on the same latitude but have different longitudes. Okay, so let's go ahead and see the solution to this problem, and you compare it with your own answer once you are done. So that's the globe. Okay, that's the equator. Okay, so that's the latitude 37 degrees south, and we have the first longitude 29 degrees east, and we have the other longitude, which is longitude 34 degrees west. Okay, so we have to find the radius of that latitude. We have to find the radius of latitude 37 degrees south. Like we know earlier, the value of the radius of any latitude is simply the radius of the earth multiplied by the cosine of the angle of that latitude. And once we have done that, the radius of that latitude 37 degrees south, is simply 5,111.3 kilometers. Now the two positions, now the angle between them is simply the sum of their respective longitudes, which is 34 degrees plus 29 degrees. Okay, once we add that, the value is there now is 63 degrees. So the distance between the 2 points from 34 degrees west to 29 degrees east, the angle between that is 63 degrees, and that forms an arc of a circle that subtends an angle of 63 in between them. Using the formula to find the length of an arc, which is theta over 360 times 2 pi r. So we will now find out that the length of the distance between the two positions is 5,622.43 kilometers, and that is that. Okay, so that is all about longitude and latitude, and I believe that you have a better understanding of this topic now. Don't forget to like, share and subscribe to this channel if you find this video informative. Thank you for watching this video. God bless you.